Hello, good morning, good afternoon, good evening. So, you're here in our lesson, which is the quadratic equation. I am Randall Roraluto, a teacher of Simis at Lab. Now we're going to discuss all about quadratic equation. But first, yes, quadratic equation, right? But first, we're going to illustrate what is a quadratic equation. So first, by the very definition is that a quadratic equation, this is the definition, is an equation of second degree, here representing, meaning it contains at least one term of a squared. The standard form is ax squared plus bx plus c is equals to 0, with a and b and c being the constant or the numerical coefficient, and it is a known variable. In one absolute rule is that the constant a cannot be equal to 0. So always remember a cannot be equal to 0. So the standard form is ax squared plus bx plus c. Now, always remember that a quadratic equation, or when you say quadratic equation, always contains a degree of 2. Here, we are going to write a certain illustration. X squared plus 2x plus 4. Is this quadratic equation being considered as quadratic or not? Yes, it is a quadratic equation. Now, how about this one? Can this be considered as a quadratic equation? Yes. Okay, now it's not a quadratic equation. So we're going to always remember all of quadratic, it can be considered as a quadratic if it contains a degree of 2 in the term. So is this clear? Next, we're going to, here are the certain example of a quadratic equation of a standard equation. Now, as you can see, all the examples here contains a degree of 2. It's because they are all quadratic. Now, for our next example, as you can see, a standard form is composed of ax plus b, or ax squared plus b x plus c, where c is the constant term or numerical value for c. For now, we're going to write a is equals to 6, b equals to 11, and c is equals to 35, right? Now, remember that signs may differ given each equation, given problem. So this is just our basis for our standard equation. Now, for example, here in sample number 2, we're lacking with bx. Can this be considered as a standard equation? No, it's not being considered, but also be called as a part of a quadratic equation since it has 2x squared minus 6, it has 2x squared, also with the x squared, also with this one in the bottom part, also in the x squared. Now, always remember, then in writing the code in the standard form, we're going to find, for example, here, write an example here. So we have x, or we have x squared plus 4. Okay, this would be plus 4 plus 5x is equals to 0. Now, to transform this one into standard form, always write the A, B, C, or this equation. So RA would be AX squared. Then, okay, you might ask, where's the A in that one? It is being called that it is imaginary since all x, it contains an imaginary one, or it contains 1 here. Then next would be the bx, which is the 5x, and 4, which is our constant. Since we're going to call that constant, it's because he or she hasn't have a variable beside him. 4 doesn't contain a variable, right? So we're going to rewrite that one into this kind of equation. X squared plus 5x plus 4 is equals to 0. And that would be our standard equation. Okay, just a recap for our lesson for today. Always remember that a quadratic equation must contain a second degree, or this one. Next, in writing the standard equation or standard form of equation, always try to follow this type: ax squared plus bx plus c, where a should not be equal to 0. And that's for our lesson for today.